Hello, everyone. Happy Monday if you're watching it on Monday. This is your pre-recorded lecture video that would have been given on Monday if we had class, but no class on Monday. So just watch this video in replacement of class, and that's all you really need to do. So watch this video. I recommend trying the examples with me while I do them to make sure that you know what you're doing, since normally in class I would give you time to stop and do examples and then we talk about them, but try doing these on your own and just see if you can do them. So let's just go ahead and get started. I just want to sum up what we did in class on Thursday. So Thursday we talked about one method of hypothesis testing, which is referred to as the traditional method. And then today we're going to get into a new method that uses something called a p-value. But let me recap the traditional method. So our step one is to always state our hypotheses and identify the claim. So let me go back to the example we did on Thursday. So first we state our null and alternative hypotheses, which the alternative one is the claim here. And then step two is to find this thing called a critical value using the appropriate table. And using this critical value, we determine our critical region versus non-critical region. And then we're able to say, hey, if the test value that we compute falls in this critical region, then we can reject the null hypothesis. And if it doesn't, then we cannot reject the null hypothesis. So in our example, our critical region started at 1.65. Our test value we found was 1.43. So this fell on the left side of the critical region, which meant that we could not reject the null hypothesis. That's the traditional method, which involves using this critical value, critical region, and then the test value and seeing where it lies, and then deciding to reject or not reject. But we're going to talk about a new method today, which is called the p-value method for hypothesis testing. Let's just get right into this. So like this says, we usually test hypotheses at common levels of significance. So we define that thing called alpha, which is your level of significance. And ones that we've used are 0.05 or 0.01. And then it says, recall that your choice of alpha depends on the seriousness of the type 1 error. So when we define the level of significance, we defined it in terms of the type 1 error. So based on how serious a type 1 error would be, you may want to choose your level of significance based on. But there is another approach to doing this, which is known as the p-value method, and it utilizes that thing that we're going to call a p-value. So the p-value, or the probability value, I will only call it a p-value. It's the probability of getting a sample statistic, such as the mean, or a more extreme sample statistic in the direction of the alternative hypothesis when the null hypothesis is true. Okay. The p-value is the actual area under the standard normal distribution curve of the test value or a more extreme value. The smaller the p-value, the stronger the evidence is against the null hypothesis. And we're going to use table E to find p-values when we're using a z-test. So we're going to do a few examples with relating the p-values to if you can reject the null or not. And then we'll get into doing the same example that we did on Thursday, but we're going to use the p-value method instead of the traditional method. So hopefully you can see two different types used on the same example to compare and contrast and see the differences between the methods. Okay, so we have some rules with p-values and how they relate to rejecting the null hypothesis or not. So if our p-value is less than or equal to alpha, which is our level of significance, then we can reject the null. But if our p-value is greater than alpha, then we cannot reject the null. So that's how those two things relate. You find your p-value and you see how it relates to alpha or your level of significance, and then based on that, you make your decision on rejecting the null hypothesis. So like I said, let's do some examples with how the p-value relates to rejecting or not first, and then we'll do that example from Thursday one more time. Okay. So our first example says, suppose you have a left-tailed test and find the area in the tail to be 0.0489. What is the p-value? Okay, so remember up here we defined the p-value as actually the area in the tail. So if you're doing a one-tailed test and you find the area in that tail, that is your p-value. So that's not too bad. We're given the area in the tail. So in this case, our p-value is going to be 0.0489. And you'll see how to find that area in the tail in the next example, but just for now, take that area in the tail to be 0.0489. All right, and then we have another question of if we will reject this at a significance level of 0.05 or at a significance level of 0.01. So in each of those cases, what would we decide to do? So let's do first the case where alpha is equal to 0.05. So our goal is to see how the p-value relates to alpha. So in this case, our p-value of 0.0489 is definitely less than 0.05. And like we said above, the p-value is less than alpha, then we're allowed to reject the null. So at a significance level of 0.05, we can reject the null. Everyone's favorite saying, reject the null. So let's look at a significance level of 0.01. So let's compare the p-value with 0.01. Well, in this case, 0.0489 is going to be bigger than 0.01, which sadly means that we cannot reject them. Okay, so you can see the difference here. We have two different significant levels, and then we have different results based on the p-value and how it relates. But that was a one-tailed test, so let's do a two-tailed test. So this one says, suppose you